I think we are live now. Yeah, we should be. All right, great. Hey everyone, I'm Alex Davis from Tezos Israel, and we're about to start our workshop for our joint workshop with MadFish.Solutions on how to build, test, and deploy your own token on Tezos. I'm going to walk you through a small introduction of what is Tezos and what are we doing at Tezos Israel. And then I'm going to introduce Anastasiia from MadFish.Solutions, who's going to be giving you this course over the next 3 days. So let me share my screen with you and give you a little, you might be a little familiar with Tezos already, you might not, but in any case, here we go. There we go. So Tezos, it's built to be secure, upgradable, and built to last. Essentially, Tezos has been built keeping in mind several things of the first sets of smart contract blockchains that came out, like Ethereum, which lacked governance and had problems updating. So some key properties of Tezos: it is a public blockchain. It does not use proof of work. It uses what is called liquid proof of stake. It's a protocol with on-chain governance so that every stakeholder can vote on how they want the protocol to evolve. And we just saw that a couple of weeks ago. We'll see that soon. I'll get into it in a minute. Again, everybody who holds a cryptocurrency can delegate their rights to bake and their associated voting rights to a baker. And that baker votes on behalf of his delegates, similar to a representative democracy. And in terms of security for the network, Tezos facilitates formal verifications for its smart contracts, which is used in essentially industries where there's a very low margin of error for mistakes, similar to nuclear reactors, aerospace, and now Tezos is bringing that to financial applications. The on-chain governance principle is actually incredibly useful for Tezos. Tezos has gone 4 updates now. We're in the middle of our 5th with 0 hard forks. As you're familiar with Bitcoin, perhaps, and well, I hope so if you're here. Bitcoin hard forked into Bitcoin Cash, taking with it developers and parts of the community, which also then forked into, again, Bitcoin Cash ABC and Bitcoin Cash SV, further forking those communities. And so Tezos doesn't have to suffer from that. Ethereum, the largest smart contract network, has forked into Ethereum Classic. Now, even just to upgrade, it is, it's got now Ethereum on proof of stake on the Beacon chain, and Ethereum still has proof of work, with only 1% of the proof of work coins migrating over to the proof of stake coins. So on Tezos, the on-chain mechanism completely avoids hard forks, and there have been 0 hard forks on the Tezos network over the period of almost soon to be 5 upgrades. The mechanism's relatively simple. Anyone can inject a proposal. Any baker can inject a proposal, and where then other bakers essentially upvote on that proposal, where it goes into an exploration stage, where the top ranked proposals move forward. The top voted on proposal would move into what's called the testing period, where a separate test chain is forked from the main chain, and it essentially acts as if it is live on that test chain. And once it essentially finishes that testing period, it goes to a promotional vote period, where the bakers get to vote on the proposal if they want it or not on the upgrade. And once they do so, whether it's yay or nay, the test chain will either get implemented, and you have the upgrade migrated directly into as like the main chain, or it'll essentially drop off. A little bit of history. We've had the Athens protocol, which reduced from 10,000 XTZ to 8,000 in order to start a bakery. Then we had Babylon, Carthage, Delphi was implemented last month, where it reduced fees by 4 times for transaction costs and increased gas limits. And our upcoming update, which is called Ido, is bringing privacy and via sapling to Tezos, and creates a 5th period where the upgrade in the upgrade cycle where nodes can update their software more easily. And also ticketing, we'll get to that. A little bit about Tezos Israel. We're an innovation lab that serves the Israeli community and abroad, and educating and training developers while building and advancing blockchain technologies for the Tezos ecosystem. Our mission is to build awareness and integrate Tezos into different essentially like Israeli high-tech ecosystems and government offices. And so we've currently got several projects going on. Tezos Blockly, which is similar to ETH Scripter. It is a no-code smart contract development tool where you can drag and drop pre-built pieces of code together in order to build smart contracts. OneTez, which is similar to Gitcoin, and it allows for freelance developers to access, for essentially companies to go and offer bounties for finding bugs, finding freelance developers, etc., for the Tezos network and to pay in Tez as well. We also work on implementing and integrating blockchain projects for Tezos and setting up Tezos nodes in Israel and around and in the region. A little bit on the foundation. They did a ICO in 2017, raised about $232 million. Today it's closer to $1 billion. So there's a war chest behind the blockchain. A couple use cases that have made it popular on Tezos. EcoSafe's a financial STO platform coming out of France who have tokenized the Mansion of Versailles amongst 30 properties. There's also the St. Regis Resort, which is a ski resort in Aspen, Colorado, which is tokenized and tokenized about 18 or 19% of their stock. Something more recent due to the coronavirus, Wexicon EQ basically airdropped voucher tokens, about 10 Swiss francs to citizens in local areas in order to incentivize shopping at local and small businesses. And those about those 25,000 inhabitants essentially were using a payment platform built on Tezos. The Bank of France has chosen Tezos as the lead platform for testing the Euro CBDC, and so they're testing that currently. And China has chosen Tezos of one of these 6 main networks for the digital yuan. That's it. If you've got any more comments, questions, or if you'd like to reach out to us, you can at contact@tezos.co.il. Of course, there's also the other 2 links for the official Tezos site and another link for starting to build on Tezos. That being said, let me unshare my screen and there we go. And introduce Anastasiia. Anastasiia is the lead developer for QuickUSwap, the second decentralized exchange that is coming to Tezos, built by MadFish.solutions. You might have heard that name before because they also built the only Chrome browser, well, the only browser extension wallet for Tezos, similar to MetaMask. So without further ado, let's bring Anastasiia in so you guys can learn and deploy your tokens. And guys, welcome Anastasiia. Anastasiia, how are you doing?
Really nice to meet you. Thanks for introduction. And during the course, I think we will dive into the smart contract development on Tezos. We will basically build a simple FA1-2 token on Tezos. We'll extend its functionality with robotics2z and then build yield farming. Also along with it, you will learn how to test and integrate the solution to the front end and many other things that are really useful for Tezos development. Now let me share my screen.
One final thing before we start getting into the GitLab and learning. This is going to be the first course where we issue a digital certificate, a semi-fungible token for everyone here who attends and completes the course. So you will be getting a token that essentially contains your digital certificate of completion. It is a first for Tezos. And we'll be handing those out at the end of the course. And also for the competition for the Bitcoin Suisse crypto notes and XTZ prizes, for the Tez prizes, I will be sharing in the Discord channel the guidelines and the framework for that competition. So Anastasiia, the floor is yours.
Thank you. So we'll start with Scratch. We will just try to create a new project called 1.2. And it will take some time. For that, we will just explore some theory. You probably heard about such a thing as TZIP. It's some proposals, some documentation for Tezos that are intended to make the ecosystem better. And some standards I explained here. There are 5 standards that are related to ledgers, asset, and tokens, but there is only one that is finished. It is TZIP 7. Which introduce FAR 1.2 token that we will implement. As far as it's the only token standard that is finalized, we will build exactly it. And let's explore it. It resembles ERC20 token. As you can see, there are 5 basic methods that should be implemented. First one is transfer. And we need to specify sender and receiver and the amount. The second is approve that consumes spender and value arguments. And there are 3 view methods: get allowance, get balance, get total supply. But the interesting fact about these view methods that they're not similar to Ethereum view methods, because we always need to provide the contract which the contract address that will receive this result. So it's mostly not for the front-end usage, but for usage by other contracts. It's probably quite tricky to understand, but when we will implement them, it will be easier. And one more thing that I want to mention is metadata. There is no standard. The standard does not introduce how it should be implemented. So you can have any data inside of the storage of the contract. It's up to you. And it sometimes creates some problems to read it from front end because it's not unified. And probably that's it about this standard, and that's what we will do today. I still see that the project is not ready. We need to wait. Oh, by the way, I can tell a little bit about the other standard of tokens, which is introduced into ZIP 12. Yeah, it is a multi-asset token, but it's the work is in progress. But the whole community is eager for this standard because it's more interesting than simple FAR 1.2 token. Yeah, we see some errors, but it doesn't matter much. We need to make little changes, as we discovered this morning, because there were some updates and, oh shit. Sometimes I have some issues with my idea. As we discovered this morning, we will have some problems with packages, and with Ganache we need to update the version here. It should be 11. So. Shit. And now we can install dependencies. Sorry, that's my mistake. I just forgot to move to the project and I expect something. Yeah. Yeah. Now we can just look at the structure of the project. I still don't know why my screens are not working as expected. And we can look at the structure of the project. We have a contracts folder, which will contain all the contracts that should be compiled and actually deployed to the network. The migration folder consists of scripts that are used for deploying the contracts. Scripts contain the only thing, which is accounts that are used to deploy contracts. And test folder is currently empty, but we can place tests and run them with truffle. Also, we have some other stuff. Yeah, we have truffle config that is used to specify the network and where we actually will deploy the contracts. And actually, that's it about the project structure. If you are familiar with Ethereum development, you're probably familiar with this way of organizing folders in the project. And seems like we have installed everything we need. And we can try to run the sandbox. Yeah, that's it. We see that it's listening on the ports. This one port, yeah. And now we can explore the contracts itself. Here we have the simple contract, which consists of two interesting structures. First is type alias for migrations, and the second is function declaration. Let's start with migrations. Indeed, we have a special keyword type, and then the name of alias, and then the type that will be used under the migration. Here it's record that consists of two fields, owner and last completed migration. Each field is associated with some specific type. Owner is associated with address type, and last completed migration is associated with int type. All the fields are separated by a semicolon. You can see that the record is like wrapped with and, but it's old style of writing the code, so we can just use another syntaxes, which is recommended to use currently. And we have another thing that is function declaration. It is called main, and so each function should have the name and some parameters and their return value. Here we have two values. First, it's completed migration and migrations. Of type migrations, I really hate that they decided to make the type and the variable with the same name. And we have return value, which is tuple with two values, list of operations and migrations. And main is really special function. Because it is not typical because it must have exactly two arguments and exactly this type of return value, because it's main entry point of the contract. And as main function, it always consumes the first argument of such a function is the action, the parameters that the user sent to the smart contract. And the second parameter is the storage that is stored in blockchain. So the user does not provide it. He just called the main function and provide his value, and the storage is read directly from the blockchain. And the return value is list of operations, which are some other actions to other smart contracts or transfers to other addresses. And the second argument in tuple of the return value is actually the storage, the updated storage. So we can somehow modify it, and then we must return it in the end of the main function. And we have the function body after is keyword. We do something there and then return value. If we talk about what exactly is happening in the scope of the function, we see if then else statement, if some condition, then we do nothing, and otherwise we need to update the field last completed migration of storage of our record migrations. And then we will return updated value. It's interesting that we see the old style of the syntax here. We shouldn't use sender right now. We need to use it as a part of Tezos namespace. So this one will be not that will be proper way to use sender. And we can try to migrate the contract. First, we will try to compile it to see that it's fine. Yeah, so we see that compilation was done properly, and now we can just migrate and deploy our contracts. As you can see, the new block was baked, and we see the hash of the transaction where our contract have been deployed. And interesting fact about this construction, you probably were curious why we have this then skip if we just can't skip literally it. But if we try to do that, we will find something interesting. For instance, if there's a sender, then we will update it. We can try to compile it. And we see that such a construction is not acceptable in Lingo, so we always must provide both cases, then and else. And now we will try to create our own file with token. Much more interesting. And we will start with designing our storage. We will need to type account, which also will be the record, right? With two fields. First is the balance of the user of type not its unsigned integer, and we will need allowances, which is some kind of dictionary that contains amounts that are allowed to spend by some addresses. Map is really the dictionary where the key is of type address and the value is of type not. That's this unsigned integer. And then we can create storage type. We will need total supply in our case, right? We need to know how many tokens are in use. And we need some kind of ledger like this. It will be a big map with address type for keys and not for and accounts for values. Right? The difference between map and big map is in the efficiency. Like big maps are lazily loaded. That means that it's cheaper to use them when we have a lot of values and we don't need to put them all on the stack. But when we use map, that means that all the values will be present on stack, and yeah, it's not good. But if we have a lot of pairs. But we can't use big map here because it's part of another big map. That's why we need to we need to have map here. Yeah. And now let's try to introduce types for entry points. As we just discussed, I lost this page. Erase it. So as we see, we have 5 functions here, 5 entry points here, and we need to provide some types for all of them. So it should be interesting. We will try to transfer type. Yeah, is well. There is interesting thing that it is. We should make our contract compatible with other Michelson. We should make it compatible with Michelson version of it. So we can't use record here because then annotations can be messed or the order of these arguments can be different. So we need to do it with such a thing as Michelson pair. It is a special type. It is really a little bit terrific, I would say, but I think we can cope with it. So according to, I don't know why do I have it? Sorry. So we need to create Michelson pair that consists of first argument will be, I would say parameter will be address from, and the second element in this pair will be another Michelson pair that consists of 2 elements, address to and not value, like that. I hope you can understand what I mean. So let's try to do this. First, we need to specify the type. Then we add the annotation from, right, as it was there. Then we create another Michelson pair, so pair, right? And say that it won't have any annotation. And Michelson pair will contain other 2 elements, one of type address with annotation 2, and not type. Another element will be of type not with annotation value. Awesome. Next, we will have the type proof. A proof type. It will consist of will consist with 2 elements, one of type address and another of type not, spender and value. So I think we can remember that. Address spender and not value. The next one is address and address spender, only spender. Okay. Sorry. Yeah. It's allowance. But as you can see, it is the view type, and that's why we need to add add another element and explore this type because we need the return the contract that will receive these values. So we will actually wrap it all in the another Nicholson pair. And a contract not here with no annotation. Sorry, I were using the wrong thing. Yep. Awesome. And the next one is get balance. So let's call it balance type. Once again, balance, yeah. Once again, we have address owner and not value here. So it will be just pair of owner and contract. Yep, cool. And the last one is total supply type. We need unit type here because we do not need to provide any special parameters, and we will receive net value, not value. So it was the most difficult part to write these types. Other things will be much easier. Now we will declare the type of action. As you remember, we have action here, like the parameters that the user provides to execute some function. And we need to wrap all of them, all of these types, into one type that can be provided to the main function. For this, we will declare type action, let's say, that will be of option type of the type that consists of subtypes. And let's try in this way, transfer, then approve, then get balance, right? It should be from the big letters. It starts with big letter, and get allowance, get total supply, and all of them will consist of some specific type, which we have declared before. But I think I need to replace them. Yep. So our action type will consist of such subtypes, and then we can just declare main function that will have const action of type action and s of type storage. Then it will return tuple with list of operation and with storage. And just to check that the syntax is proper, is fine, is clear, and is correct, yeah, we will simply return the empty list with operations. And the same storage. So we will check that all this construction are correct. and we will try to compile it. Yeah, so we see that we have no mistakes and we can continue working on it. Now, we will unwrap, I would say, our action so that we can receive these values from the action and make different operations based on the user action and the entry point that user used. Okay, so is keys of I'm too lazy to to retype it. And I will just do that. And now we will get some values of type that is introduced in the subtype. I mean that if the action was of type transfer, then we will receive the parameter of type transfer type. If the user provides the value of type get balance, then we will receive here the value of type balance type, like that. And in order to do something with it, we need to make this arrow and then return some value. I think it should work right now. Yes, cool. And now we can start introducing some new functions. We will start with the easiest one, which is get total supply. We will need to create some operation to the contract, to the receiver contract, with the value from our storage, which is actually total supply, right? So let's start with declaring the function get the total supply, right? Total supply. That will need the argument of receiver contract. And to the storage itself. And it will return list of operations. And let's create this list. There's this operation, and we need to return the value, which is as total supply. So that is the value that we will return to the contract. Then we need to provide the value of Tezos that we will send to the contract. And we need to specify the receiver of this transaction. And actually that's it. About the get total supply, we will need to use this function here, yep, and provide the argument. Yep. Things like that. And oh, sorry, not operation but transaction. That's my mistake. And we have the first function. We see that it has been compiled properly, and I didn't explain what actually where and one is. Sorry, I was distracted by the message. So we have get total supply, yeah, and we have the pair here. We have two elements in this pair. This one is 0 element, this one is 1 element, so we need this one, so we put 1 and we receive this element, and we pass it to the function. That's why it works. And next we will implement the other function, which is called get balance. But we will need more arguments here. We will need owner of the we will need owner address here, and then we will have receiver of this response and the storage, like in the previous case. Now we need to get this balance somehow, and first of all we need to get the value from the ledger. We can do this by simply calling ledger owner, and you probably expect that to work, and we can do something like that. But if we just try to compile it, we will see that it's not working. Yep, because when we receive value from the ledger, it's actually of the type option. We either have the value there or we don't. That's why we need to unwrap it as we did with an action. If the ledger of type none, then we need to do something. Yep, and if there is somebody there, then we will get the account, and we also can do something with this. And as soon as we need to get the balance, if we do not have any value in the ledger, we can say that the balance of the user is 0. But if we have something in the ledger, then we can just say account balance and receive the value and actually return it from the function. Yeah, it works. But I think you probably have some questions about what we have doing, because I'm talking a lot, and if you have any questions, you can ask it in the chat if you didn't. So at least I can see any questions. Okay, so we will implement the last one of the view functions, which is get allowance. Oh, what is not? I see the question. I explained that not is unsigned integer. Yeah. So, any other questions? Okay, get allowance. So get allowance, we will have owner, we will have spender as an argument, so it will be a little bit bigger. And as far as we will need to get not only the value from the ledger, but from the allowance map, and we will again have the case, it's better to have the separate function for for their account. So we'll just comment it out and create another function for retrieving the account from this storage. Get account, let's call it. Then we will receive owner as an argument. I just see that something's happening in the chat and okay. So we will create the function get account and we will read this account from the storage. Address. We will receive the storage as an argument, storage, and we will return the account. Now we will introduce the body of the function, and actually we will just copy this part of the code, but instead of 0, we will return a record with 0 balance. And balances. We can declare the empty map in this way when we just create an empty map and then show the type of such a map. That is an empty map, and that is the default state of the account if it does not exist in the ledger. Otherwise, we will just return account, and that will be the method for getting account from storage. And now we will update get balance a little bit. We will add the body to this function. Yep, is block. And we will declare a variable here, or actually the constant called account of type account, and we will get account owner storage, and yeah, and here we can just remove all of it and left it like that. And by the way, I see that I forgot to use it here. I had to do that before. So we need to provide some arguments here. And as you remember, we have two values here. The 0 element is owner and the first element is receiver. So we can simply ask for the 0 element and for first element, and it should work. Yes, address is the type, the usual type in Lipo. You can use it. And as you see, the code have been compiled, and that means that everything is fine. And now we will just declare another type, as another function. Get allowance. As I said, we have two arguments, owner and spender here. And we have receiver and storage, right? We need to move get account a little bit here because we can use only functions that are declared before our function. And here we will do something like that. We need to get the account. I just copied this code. But we also need to get allowance in a bit similar way, like it will be not. So we have case, account, allowances, and then we have spender here, basically. And again, we have two options. First is none, when the value is not present in the allowances map. And then we say that we just 0. And we can have sum. And then we can just return this value. So we can return it here, and that's all we need to do in this function. And we need to add it to our main function to make it reachable, and in order our function has some functionality. And we need to give proper parameters. As you can see here, we have Nicholson pair that consists of one Nicholson pair and contract not type. And let's just get these parameters. As we see, owner is the 0 element of the pair. Then the spender is first element of the 0 element of this pair. And then receiver is just first element of the Nicholson pair with arguments. So now it should work. But it don't. Let's see what's wrong. Yeah, I forgot about storage here. No, it's fine. So the code is compiled, and we can proceed to more interesting functions. The next one will be a proof, and is not view function anymore, and it should be much more interesting. Let's create the function. Spender of that address, and we have amount. This can be spent by this user, and we have storage. This time we will modify the storage, so the return type will be storage. And we will create the body of this function block with storage. So as you see, we will return storage. We will do some actions here with the storage, and it will be modified, and then we will return it here. And what we should do? We need to get the account, just like we did it here. And we will modify it. Account, we have allowances, right? And we need to make it, to update the value of allowances for the spender. We need to make it equal to value that had been provided by sender. And by the way, we won't have an owner here, but we will have the sender here. We will update the account for him. And you probably expect that it will work and the value will be modified, but it's not true. If we modify account, it's a local variable, but it's not storage. So in order to make it changed in the storage, we need to update the account itself. So yeah. That's it. And that is a proof function. We will need to add it to the main function. And we will read the parameter here. As you saw here, we have the pair with two elements. 0 is spender and the first is value. So we need to have 0 and that element here in this order. Okay. As you see, it had been compiled, but I think you have some questions. You asked where Tezos sender come from. It's global variable, so it's available when someone calls the function. So it's always available. There are some functions. I probably can just find you the list of them, or not now. I can share it later. So there are some variables that are available, like Tezos sender, Tezos origin, if I'm not mistaken. So it's available. You just need to know that they exist. There is a Tezos value when you can get the amount of Tezos that have been sent along with the transaction. So it's not a problem. You can find it in the global scope, yeah. So, and we can go to the next function. It will be it also interesting function, and we will have owner, and we will have receiver. Also, we have value and storage. And here we will need two accounts, indeed. The one for owner is another one for receiver. So let's call it source and destination. And as you probably expect, we will need to update them in the end of this story. So we will just copy them and put source here, list here, yeah. And oh, that's it. Also, we will need to check approve if the sender is not equal to owner. Then we will update balances, and we will what we will do. And we will check the balance itself. So it's our plan for this function. Let's check that the sender has the right to transfer tokens, actually. To do that, we will check that the sender is equal to owner, to owner, yeah. Or no, it's not the proper name, I guess. So let's call it from sender and replace them. So I don't like it. Let's, because it can create some issues with the naming. So let's call it source or player, I don't know, source. And let's check that the sender is equal to source. And if he is, then we just skip the check. Otherwise, we need to check that the user has an allowance and the right to make this transfer. Okay. Then let's get the allowance of this user. We have been doing something similar here, so we can copy it to do not repeat ourselves. But instead of account, we will have source, and instead of spender, we will have source that I have been mistyping. Source rate and to the sender. So we will check if the sender has the right to spend tokens from source. And we'll do it here. If allowance is bigger than value, or smaller than value, I would say. If allowance is smaller than the value, then we will fail with an error, like not permitted, let's say. False, we will just skip it. And if it works and the allowance is higher than the value, then we need to make it smaller for the user. And we will do it in this way, allowance minus value. But if we try to compile this code, we will see something interesting. We see that it won't be compiled, but I can see the proper error, but it had to be here. Indeed, the problem is with type of the value, because this construction will give us not type, but integer. It's really tricky stuff about the math in Tezos. Sometimes we get really weird types. For instance, like that, we subtract from one unsigned integer another unsigned integer, and we receive integer. It's very weird, but we can handle it using ops, and then we will receive natural number. Yeah, and now it should be compiled properly. And I have skipped work here. That's my mistake. Well, it's interesting. It seems like I missed something else. Interesting. Yeah, I forgot that source is reserved word, so that was the case. Yeah, and now we will replace it with owner, and now it should work. That's why I really hope that they will remove the opportunity to use sender and source without Tezos namespace, because sometimes it creates unpleasant situations. 41, which is what? Yeah, listen. And one more. Yeah, finally. So I have missed these semicolons. And yeah, we have checked the proof. Now we can check the balance in a little bit similar way. So I'll just copy that and replace values here. First, it's source balance. If it's smaller than the value, then we can transfer the tokens, and we can say that the balance is too low balance, right? And yeah, fail with low balance. And let's update the balance. For source, we need to make it smaller. It's extracted. And we need to make this conversation. Yeah, so we will receive, once again, we will receive integer value here because we subtract two unsigned integers and we receive integers. Yeah, it's good. And we need to update destination in this similar way, but we will add this value. Yep, it's like that. So it had been compiled properly, and we just need one improvement. We need to use this function in our main function, because now if we will look into the build and we'll look into the compiler code, if we really decide to do that, we won't find any code related to transfer because it's not used. And if the function is not used, it's not appeared in the compiled version of this code. So we need to add it here. We use transfer, and we need to figure out what is the order of the arguments here. Here we have from, to, and value. And from is the zero element of outer pair. So it's pair 0. Then we have 2, but it's the 0 argument of the first element of outer Michelson pair. So it is 1, 0. And the last one is latently 1.1. And now it should be compiled properly.
Hey everyone, Anastasiia.
Yeah, hi.
Way to go. Wanted to chime in here and see if anybody had any questions that they can ask, and like kind of have like a little Q&A session to make sure everyone's up to speed on the same page. Everyone that's watching, if you can post any questions that you guys have in the chat on the side, under the stage side, we'll have Anastasiia go over them and keep you informed.
I see a weird question here, or why use legal and not solidity on remix, because it's different languages, and we can't write on solidity for Tezos. And another question, in transfer function is in source to the sender? Not all the time. As we said, we can have owner, or as it was source, and it can be like the sender may be the different person and not the one who will spend his money. Like we will charge these tokens from the another account, not from the owner or source. About the if statement, why you use skip instead of nesting in else. Wait. Mhm. Um, I'm not sure that I understand the question. Why exactly? Um, I mean, about the if statement, why you skip instead of nesting the in else? Um, anyway, we can't avoid the necessity to have then and else. So I see no way to do it in a different way. Then we use also skip. If yeah, we can. Sorry, no, we can't. Then fail use also skip if allowance. Oh yeah, actually yes, it's true. We can do it. Yeah, you're right. We can just do it in this way, and it will be compiled properly. So, something was about SmartPy. I said, hello, why not SmartPy? I'm not sure. I have thought about it, but I prefer Lego. You can try to work with it, but I prefer Lego. Mhm. Mm, I can't see any other questions. Well, we can move to migrations because it's. I also wanted to show you how to deploy your contract, and maybe you will come up with other questions. I don't know. So, in order to do that, or yeah, in order to do that, we need to create another file and to lazy to write from scratch. So we will create, let's call it main migration. And we need to specify the name of artifacts. What are artifacts? It is these two files you can see that is artifacts. And we can have an access to them due to truffle. The name of the contract is inherited from the name of the file where it is placed. So in order to get the access to token file 1.2, we need to say to place its name here. And we need to deploy it. In order to deploy the contract, we need to provide two things. First, it's name of the contract, and the second is the type of storage, the initial storage of such a contract. We'll do it a little bit separately. Mm-hmm. And as you remember here, we have the record with total supply and ledger. So at least these two values should be present in our initial storage. And let's say we have total supply of 1,000 tokens. So our total supply is total supply, and then we need to provide some value for the ledger. As I said before, Big Map is kind of similar to dictionary, where we have keys and we have the values. We will create the ledger where the whole supply is devoted to the deployer, To get the address of the deployer, we need to go to accounts, and the 0 account here will be the deployer. So we will just say 0 account. Yep, 0 account will have balance total supply and allowances. Let's say nothing. So our deployer won't allow anyone to spend his tokens. But if we try to deploy this in the way it's organized now, we will get an error. I wish you to see it. And we see that the value must be of type Michelson map. In order to make it possible, we need to install the package. We will play with this library tomorrow more. Today, just a demo how to use it. It will take some time, but I can start writing code before it will be installed. So we will need this Michelson map. I guess that is. Right. No? There is something wrong. I don't know why it's not resolved yet. But alright, let's try to compile and see what's going on. Should be somewhere here. Oh. So it had been resolved. Alright. And we need to make our ledger to be of type Michelson map, as well as allowances, because according to our storage design, ledger is of type big map and allowances is of type map. So to that, we use Michelson map from literal. Hey, literal. And the same here. And we see that it's processed. We have the hash of the operation and the address of newly deployed contract, and it's pretty cool. So we did it, yeah, we succeed. We have deployed, we have developed, implemented, and deployed token 412. So if you have any questions, you can ask it. Someone asks me how long I have been writing on Lego. I'm writing on it more than a year, since the September of the previous year. But do you have any technical questions? Yeah, it's Pascal Lego. Yes, sure. I will share it just after our lesson, our lecture. And by the way, you will have the homework. Your task will be to extend the functionality of our token and make it similar to the simple version of Wrapper.txt. Your task will be to implement two other functions. I will. Oh, unfortunately, I can't ask. I can say what's wrong with your code because I can't see it. Interesting. I can show you get account. Maybe it can help. Yes, I probably can do it right now. Yeah, I will create the repo and send you the access. It's very good. How's that? Oh, sorry. Yeah, sure.
Hey, Anastasia.
Yeah.
Regarding Jeff's question on the homework, can we post something in the Discord channel alongside the framework for the competition? I'll be uploading that PDF into the Discord channel after today's part of the workshop. And can we also add something like a little PDF, just quick couple lines on what the homework will be?
Yeah, sure. I will share it with you and you can post, okay?
All right, sounds great. So the homework will be added to this Discord channel, everyone, and alongside the framework for the competition. So while you're going through this, also keep in mind like how you'd like to use a token, what its platform, and what type of platform, and you'll get more info at the end.
So I have shared the repo in workshop session, yeah, and you can look at it and probably compare with what you have. Maybe you have any other questions, maybe related to migrations or whatever. And yeah, what about the homework? Someone have? Well, let's just move to migrations. What is the migration process? Well, actually, migrations is deployment to the network, and when we call truffle migrate, I have been doing it a little bit earlier. Yeah, when we do truffle migrate, actually it starts with compiling all your code. So if you want to migrate, you do not need to make compilation before. And then it starts to process all your scripts in the folder migrations. Actually, you can specify another folder in your truffle config, but we will discuss truffle config a little bit later tomorrow, I guess. And they are executed, and your contracts are deployed to the network that is specified in the truffle config. If you run a truffle migrate without network flag, it's deployed to your local testbed to deployment. But if you say, for instance, deploy network cartridge net, then it will be deployed to the real testbed. I can say that it's published, it's actual deployment, it's a little bit different terms. And basically in Tezos, it's common to use word origination for migrations. Migration is the term for Ethereum deployment. And once again, I can try to talk about your homework, about set two functions that should be implemented. First, it's mint or deposit. When the user sends some XTZ to the contract, it should be processed as the action for minting new tokens. So the user sends XTZ, and you must add the balance to this user, the same as the amount that he had sent to the contract. And then another function is redeem or withdraw, when the user can receive his XTZ from the contract by burning his FA12 tokens. That will be your homework. And tomorrow we will test these contracts along with your functionality, your new functionality. Any other questions? Yes, if he brings his tokens, and that's why he has some amount of tokens on his account, his balance, his in his ledger, then he is allowed to burn his tokens. So that means that everyone can bring his XTZ, he can wrap it and put to the contract and receive FAR1 tokens in exchange for it. And then he can come to withdraw his tokens and burn his FAR1 tokens. If you are familiar with wrapped S, the logic is similar. So someone sends XTZ to the contract, receives FAR1 in exchange. He can come back, burn his FAR1 token to the contract, burn it, and receive his XTZ back. Yeah, absolutely. It's like Rapitas. It works like a Rapitas. As I said, FAR1 resembles ERC20 tokens, so we can move the logic from one blockchain to another and use all the benefits from it. Any other questions? Then probably we can finish our lesson today and you can start working on your homework. Alex? I hope Tezos Israel can say some Finnish word. I don't know. Yes, you can use the file from the repo I have shared and just extend it with your new functionality. Okay, see you. So I will stop sharing my screen and probably will wait for Alex.
Hey, can you see me?
Yeah.
Did we end already for I stepped out for 1 minute. Can you catch me up on what's going on? We're ending for the day?
Yeah, we have discussed everything.
Great, great. Did you tell everyone that, or are they waiting for me to log back in?
Sorry?
Are they waiting for me to log back in?
Yeah.
Okay, I'm hopping on. Oh, no, wrong one. Wait, how do... Backstage first. Oh, we're in. Okay, so sorry. The screen said backstage for stage. Anyways, guys, thank you for showing up today. Anastasiia, thank you so much for giving this the first day of our workshop. You'll be here also tomorrow and on in 2 days. Eric, thanks. Yeah, I noticed that a little bit after the fact. Unfortunately, there's a little bit of a overlap with the live and backstage. I'll hop in. Anastasiia is going to upload some homework for you guys, and I'm going to upload right now the framework for the competition for the Bitcoin Suisse Tezos certificates and the XTZ that'll be on them. I guess we got a Daniel. You're really welcome. Panagiotis is asking Anastasiia if the deadline for the homework is tomorrow.
Yes, before the lecture, everything should be shared. And I think we will prepare some form where you can share your links to the GitHub in order to we will be able to see it.
All right, great. So as Anastasiia just said, try and get this done before tomorrow. And we'll see everyone in the Discord chat. If you have any more questions, we'll be there answering them as well. Until then, Good night.